Here's another question. It's basically expanding binomials again, but it's dealing with functional notation. So they give you an initial function. So they say the function called f, so f of x is equal to 5x plus x squared. Okay, cool. So if I had, say, the number 2, I could plug in a 2 there, and I could figure out what the value of the function of 2 would be. So 5 times 2 would be 10, plus 2 squared would be 4. So the value of f of 2 would be 14. But then in this question, like this question 85, in section 4.2, then they say, well, what is the value of the function when instead of plugging in an x, or instead of plugging in a 2, they want you to plug in a t minus 1. So here's our function, f of x equals 5x plus x squared. And then instead of x, they want what's the value of the function when you plug in a t minus 1. So into this x here, I have to put in an x minus 1. And for this x here, I also have to put in, oh, it should be a t, sorry, t. They also want me to put a t minus 1. So really I have, let me write it out again, so 5 times t minus 1 plus t minus 1 squared would be t minus 1 times t minus 1. Okay, so this is what the f of t minus 1 is equal to. And then simplify the stuff on the right side. So it would be 5t minus 5 plus, FOIL this out, so it would be t squared minus t minus another t plus 1. Okay, so keep going, f5t minus 5 plus t squared. This would be minus 2t plus 1. And now let's simplify. Let's put our t squared first, then our t's. So I've got 5t and a minus 2t. That would be plus 3t. And then the number that we have left, so it would be a minus 5 and a plus 1. Minus 5 plus 1 would be a minus 4. Minus 4. So that's the value of f of t minus 1. In other words, it's the value of the function t when you plug a t minus 1 everywhere you see an x. Okay? Hope that helps.